Hey guys, so what are we going to be talking about today? What's our essential question?
The essential questions of this video are: what are valence electrons and how are they represented in electron configuration? That's exactly what we're going to be talking about today, and we're going to go through a few examples as well. So let's start with valence electrons. What are they exactly?
Okay. Well, I know they're the electrons that are on the outside of the atom, so they're in the like the highest energy level.
That's right. They're the highest energy level and the outermost shell. So let's put that in right here. Valence electrons are the outermost electrons in an atom. All right, and they're always in the s and p orbitals. And we'll talk about those a little bit more later on. They're never in d orbitals or anything like that. And what they're for, they're important for bonding and reactivity. Those are the electrons that have all the action. They do all the work in an atom.
So when you think about, they're on the outside, so they're the ones that come into contact with other atoms. You can kind of think about it as being like your skin. Whenever you meet somebody new, it's what's outside, it's what they see. So that's kind of how they respond to you. So that's, and I can tell from my notes that they have to have a maximum number. How many valence electrons can we have?
The most that we can possibly have is 8.
8.
That's all that can fit in the outermost shell of an atom.
Now there is an exception to that, isn't there? For like helium and hydrogen? Am I remembering that?
Oh yeah. So if an atom, like all they have is less than 8 electrons, in that case they would be an exception.
Right.
But so that's just the maximum.
Oh,
the maximum
that's true.
We can ever have.
Okay.
We also call that an octet. So atoms want 8 electrons in an octet, unless they're hydrogen or helium, in which case they're pretty fine with what they've got.
Right.
And noble gases, another thing important to note is that noble gases already have these, and since those valence electrons are used for bonding and reactivity, since noble gases already have those 8, they're not really interested in reacting with anybody else.
Right.
That's why they behave the way that they do.
Okay. So how do I know how many valence electrons, we'll say, beryllium has? What can I do? How can I find that out?
Well, we have to look at the group number. So that's why we've got a list of our group numbers right here.
Okay.
What these numbers represent are how many electrons an atom has in its outer shell.
Okay, so I bet this is going to be really hard. How many does group 1 have?
It's really difficult. 1. Bet you're never going to guess that, huh?
Okay. So group 2 must have 2?
That's right.
I bet group 13.
Okay, so there's where it gets kind of tricky.
Okay.
Since we can't have 13, right? We can't have 13.
Oh yeah, you said
electrons.
the maximum was 8.
We just ignore the 1s, and we just look at the 3s right here. So on those group numbers on your periodic table, it'll say like 13/3A. Sometimes it's a Roman numeral 3 or 4 or whatever.
I've seen that.
That's what we look at. We look at the 3 part.
Okay. So then 14 is going to have 4. 15 is 5.
That's right.
16 is 6. 17 is 7. 18 is 8.
And there are noble gases right there. There's
right.
18. They have 8.
Oh, they already have their maximum.
They do, yeah. So these ones are full.
So, to show those valence electrons, let's see, what do we... Oh, what about our transitional metals? What about groups 3, 4, 5, 6...
Oh, okay,
7,
so
8,
you
9,
noticed that those were missing, right?
Yeah.
We went straight from 2 to like 13 over here.
Right.
So the transition metals are weird. All right, we're not really ever going to talk about those a whole lot in this chemistry class. This is kind of, it's a basic chemistry class. They really don't follow any kind of rules at all. So because of that, we're not going to really talk about them very much.
Okay.
They're weird. We don't discuss them.
Right. I've heard that the electrons in those metals flow back and forth really well, and that's why they're really good conductors of electricity. So their valence electrons kind of don't really matter.
Right. They don't follow any kind of pattern, I guess, so to speak.
Right. So
I guess we can do an example, huh?
Yeah, let's do an example.
Let's see, what's the first one that we're going to do? We're going to start with calcium. Okay. So the steps to electron configuration.
Right.
Alright, the steps for that, we got 3 steps. The first thing that you always do is check out the periodic table and find the symbol. The symbol for calcium is Ca.
Okay. Oh, this has got a special name, doesn't it?
A special name? We call these Lewis dot diagrams.
Right. We probably want to write this in our notes so we know what steps we're doing. This is called the Lewis dot diagrams.
Let's see, put that right here. Lewis dot
Yeah,
diagrams.
put it right above step 1.
Good idea.
Mm-hmm.
Lewis dot diagrams. Lewis was a really smart guy who had a lot of things
Right.
to do with chemistry, so we named this after him.
Mm-hmm.
Alright, so we got the first step done. We got calcium.
Okay.
The second step would be to put 1 dot representing electron on either side, or all sides, all 4 sides of the symbol.
Okay.
All right.
So how many valence electrons does calcium have? What group is it in?
He's in group 2.
Group 2. So that means he's got 2 valence electrons.
That's right.
Okay.
So we're just going to go 1 and 2,
Okay.
and that's it. Actually, we got
Okay.
2, so that's calcium. We're done.
Right.
We don't need to go any further because he doesn't have any more.
Right. I guess step 2 would have been to figure out how many electrons there were, and then the third step would be to place them. So we kind of did steps 2 and 3 together there.
Yeah.
But that's okay.
Mhm.
So it's pretty easy to do.
What's the next
What
one?
if I have more than 2 valence electrons? What if I have, like, let's see, what is our next one we're going to talk about?
Oh, it's silicon.
Silicon. Yeah. What am I going to do with silicon?
14. Okay. Well.
Oh, group 14.
Yeah, he's in group 14. So how many valence electrons do you think he's going to have?
He's going to have 4 if he's in 14.
So the first step was to write down the symbol.
Okay. Right. There it is. Si.
Then the second step was going to put 1. We're going to put 1 valence electron
Mm-hmm.
on all sides. All right.
Okay. All right.
And then step 3 would be to double them up. But in these cases, because calcium and silicon, that's all they have, really, we don't need to double them up.
Okay.
All right, so maybe it would be appropriate to do another one that does have
Right.
one that we double
Let's
up.
just go down to step 3 and let's do one that we double up. What about neon? Let's do neon.
Okay, neon has how many?
It has 8 because it's in family 18.
That's right, it's a noble guess. So we're going
Okay.
to put our symbol right here. We got some room over here on the left.
Okay.
All right, neon.
All right.
The next step would be to put 1.
1 on each side. So that's 1, 2, 3, 4. That's half of what I need. That's not done.
Right, so we got to keep on going.
Right.
Step 3.
Step 3 is going to be to double them up after you have 1 on each side. So
Okay, let's go all the way
there
first,
we
yeah.
go.
And then we double them up.
Okay. So you only double them up after you have 1 on each side.
That's right. Yeah.
Okay.
I got
All
a little
right.
eager. I was kind of jumping ahead.
All right.
Yeah. So that's how that works. That's Lewis dot diagrams.
Okay.
It's pretty
Is that it?
simple. Yep. So make sure you get some questions down and write a summary for your notes. Little tips that might help you remember the order for the steps, things like that. How to locate elements and know what their periodic tables are. And if you have any questions, talk to your teacher.